Good afternoon, everyone. Hello, my name is Ollie, and I'm one of the co-founders of Outfield. My other co-founder, Jim, is on the call as well. I'm also Outfield's operations director, which means I oversee all of Outfield's operations, but also oversee the development of our systems and development of our platforms. I'm going to talk to you a little bit today about how we see the future of fruit farming here at Outfield. And spoiler alert, we think of it as being very data-driven and data-led. So I'm going to be talking quite a lot about data, farming data, how that can be used, the potential for that. So I want to start out to begin with a concept which is probably going to be quite familiar to a few people on the call, but I think really is useful to go through again, just to sort of set the context for what we're doing with Outfield, why we're tackling the problems we're tackling, and why we're tackling the way we are tackling them. And that concept is this idea that the world is entering a fourth agricultural revolution. You've probably heard that before. You've probably read articles and blog posts around it. But I want to go through that very quickly. What does that mean? What is that fourth agricultural revolution? How does that relate to horticulture and to orchard fruit production? So to start us off with, if we're entering a fourth agricultural revolution, that means we've got three revolutions that have come before. Now, I want to go through them very quick. The things they see revolution. So we think about that fourth agricultural revolution starting in the modern age. But the first agricultural revolution started 10,000 years ago in the Middle East, and it was the transition from humans being a society of hunter-gatherers into having settled farms and having dedicated farms. It's the cultivation of crops like cereals and the cultivation of livestock. The key point here for that first revolution is we went from a situation where 100% of the human population was involved in primary food production to a scenario where only 90%, so 9 out of 10 people were involved in that food production, freeing up 10% of the population, 1 in 10 people who don't have to think about farming, who can then specialize in things like metalworking, in religion, in scholars, to become scholars. And eventually, you know, we get this development of civilization. The first agricultural revolution, as I said, took place in the Middle East, but it spread across the world. And it took thousands of years to do that, but it eventually spread across the entire planet. It also led to a massive increase in the global population. The second agricultural revolution, we can define that as taking place in the 1700s, mostly in Western Europe, or starting in Western Europe. And what we see here is the invention of specific technological innovations, so things like the swing plow, but also organizational revolutions. So it's things like the use of larger farm units, so larger fields and larger farms, but also the use of dedicated markets for particular commodities and futures markets, innovations of that, innovations in transportation and in sales as well. That revolution, again, started in Western Europe, but it eventually spread across the whole world. And again, it leads to this massive increase in population, particularly in urban and rural areas. And we also get this decrease in the percentage of the population, the amount of the population that's involved in food production. The third agricultural revolution, we define that as being taking place in the 50s and 60s. It's often called the Green Revolution. And it was this massive increase in productivity that was seen over a couple of decades, starting in the Western world, Western Europe, and in North America, but again spreading around the world. And that was technologies such as high potential fertilizer, broad spectrum pesticides and herbicides, and the use of automation throughout food production, things like combines, so the picture we've got here on the screen. Again, that leads to a massive increase in population around the world, especially in the developed world, and the ability to grow huge amounts of food and ship it effectively around the world. So there's a few themes that run through these revolutions. Every revolution we go through, thinking about them that way, we get this increase in output, but the decrease in the population that's devoted to that output. We also get an increase in output per unit of land, and an increase in output per unit of air, per unit of energy as well. And so all the way through, we're getting this increase in efficiency. So that really sets the scene for our three revolutions. So if we're thinking about a fourth revolution, what does that mean? The fourth agricultural revolution, then, it's something, some people will tell you that it's started already. Some people will tell you that it's not quite started yet. It's a revolution which we can define as being built around a whole host of different technologies that are really coming together in our modern digital age, coming to fruition and coming to maturity, and being deployed in primary food production. It's technologies such as robotics and automation. I've got a few examples of pictures there: an automated tractor, automated transport systems. We've got a robot which is doing some husbandry and some picking on some kind of greenhouse crop. It's technologies such as drones, either being used for data gathering or used for spraying. It's communication technologies, things like 5G and things like satellite broadband, which mean you can gather data on any part of the farm and then transmit it to any part of the farm. It's technologies like the Internet of Things, where we are, the cost of putting sensors into the field has come plummeting down, the ubiquitous nature of sensors which can be deployed anywhere. It's cloud computing, the ability to amalgamate big data sets together to make sense of them and pull them into one place where they can be accessed by many people, by many different systems. And it's systems like machine learning and AI, where we can crunch that data, where we can pull out insights and we can pull out specific ideas and themes from that data and inform and make decisions in an automated or in a data-driven kind of way. All of these technologies are coming to fruition, and they're all being deployed in various guises in agriculture. The fourth agricultural revolution, then, if we continue the themes from those first three, what we're hopeful, or what we're hoping to see, what the dream is the fourth agricultural revolution is going to lead to an increase in yields, like we saw in the third agricultural revolution, in the green revolution, an increase in yields without using any more land and without requiring more resources being pumped into that land in terms of water usage or fertilizer application or chemical application, and with a decrease in the amount of labor required as well. What are we going to be putting in then? We're going to be putting in more data, and we're going to be putting in more automation. Those are really the themes that I think, the two pillars which hold up this fourth agricultural revolution: data and automation. And so hopefully by applying those two pillars, those two things in copious amounts to farms, we can see that yield increase, we can see that efficiency increase. The other things we can see from this from this new revolution in comparison to previous revolutions is it's going to start in the Western world, in the developed world, but it is going to spread around the world. And the revolution won't be complete until it does spread to all parts of the world. There are a few themes and a few other drivers which are, causing this revolution. Why is the fourth agricultural revolution happening now? Well, it's happening now because we're seeing pressures on resources. So we're seeing pressures on land usage and on water usage. And also because we're needing to be, there's a driver for us to be more environmentally friendly. Those environmental drivers on agriculture. So the use of pesticides, the use of herbicides, but also making our farms carbon neutral or even carbon negative. All of these things are coming together, and that's why this revolution has to happen now. So that's the sort of context that I wanted to talk about as we go into this and as we talk through the rest of this webinar. That's what we see happening, that this fourth agricultural revolution happening now, happening in the next few years, coming soon to a farm near you. But what does that mean for fruit farming in particular? So for horticulture, but more specifically for fruit production, for orchard fruit production, which is obviously where Outfield is very interested and where we're focused. To answer that question, I want to sort of walk you through a scenario. This is how we think of the fruit farm of the future. I want to talk you through a little scenario, and this is very heavily focused on crop monitoring, which is really what we think about with Outfield. Let's say it's a Wednesday morning. It's it's the middle of the growing season. In the morning, first thing in the morning, a box on the farm in the farmyard opens up, and out of the box comes a drone. The drone takes off automatically. It hovers for a second, and then it starts buzzing off towards an orchard. It arrives at its target orchard, and it starts an automated flight plan, which it's been tasked to do. It starts flying back and forth across the orchard, taking these pictures, gathering data. It completes its mission. It flies back to the farmyard, lands itself back in the box closes up, and the drone starts uploading some data. That data gets sent off to a cloud-based system where it starts being processed by a whole series of machine learning and AI-enabled algorithms. Those algorithms pull that data together, they process it, and they start to produce a series of maps and a series of parameters and metrics for that orchard for that particular time. That data is then sent to an application, to a mobile application. And our farmer, who's arrived in the morning, made themselves a cup of coffee, gets a notification on their mobile device, their tablet device. Buzz, buzz, a notification. Something's happening. You need to do something about this particular orchard. An intervention of some kind is required. Our farmer can review that data in the app, check that over from their computer, from their workstation, or maybe, from their mobile device while they're out in the field. From the device, they're able to interface with some automated precision systems, so they can task a system, an automated, completely autonomous robotic system to go off and do that intervention. So, for example, on the picture here, we've got an automated sprayer. This is the Gus sprayer, which many of you will be familiar with probably. So they task that sprayer. It trundles off, it leaves its garage, it heads off into the orchard, and it starts working its way up and down the rows, doing an application, spraying something or making an intervention according to a predefined plan. When it's finished, it returns back to its garage, tucks itself away, and reports back to the central farm management system that the intervention has been completed successfully, and here is the data from that. But our farmer's not quite satisfied. They want to get a second opinion. So they take that data from this morning that was gathered by the drone, they take this intervention data from the sprayer and maybe some data that the sprayer gathered as it was going up and down the roads, and that some data close up to the orchard, to the crops, puts it all together and sends it off to their agronomist. Sends it off to the agronomist and says, hey, can you take a look at this? Can I get a second opinion? Or maybe sends it to some other members of their team, tasks them to do more manual interventions across the orchard as well. This kind of scenario, we see this being repeated day in, day out on the fruit farm of the future. Data being gathered, data being processed, being analyzed and being looked at by a farm manager, being actioned upon using automated or largely automated systems, and then being shared up and down the supply chain, being shared across the farm. So how close are we? How close is this kind of scenario, this kind of data-led, data-driven scenario? Are we close to this? Is this something we can expect to see in the next few years? And the answer is yes. We think we are very close to this. So I want to talk to you a little bit about the Outfield system in particular, about how we think about data, about the things that we're doing with this data, and how we think we're getting closer and closer to this fruit farm of the future. So the first bit I want to talk about is the way that we think about data gathering here at Outfield. And for anyone on the call who's using the Outfield system at the moment or has used the Outfield system in the past, this will be very familiar to you. The picture on the left-hand side, that's a picture of a DJI Mavic 2 Pro, which is one of the compatible drone systems that you can use with the Outfield system. This is a commercially available, off-the-shelf photography drone. You can buy this drone off Amazon, off eBay, of your electronics shop of your choice. You can buy this system today, get it delivered tomorrow. You can be set up in a matter of minutes, ready to fly. And using Outfield, you can fly this drone in an automated way across your orchard to gather data. Why do we use drones? We use drones because they are incredibly adaptable and incredibly scalable to any shape of orchard anywhere in the world. So it doesn't matter on the orchard size, doesn't matter the orchard layout, the orchard shape, you can use a drone to gather across that orchard. Using the Outfield system, farmers are flying their drones on demand, following the demands of the farm. When the farm needs to get that data, they're executing a flight. The drone takes off by itself. It follows a series of waypoints. It comes back. It lands itself, and then the farmer uploads that data, or the user uploads that data to Outfield. And so, thinking back to that fourth agricultural revolution, right? The way that we need these systems to scale not just across the kind of the developed world, but internationally, to scale them across the globe, to really get penetration across the world. We think drones are a really good way to do that. So that's why we use drones. This is how we think about data gathering. So we've sent the drone across the orchard. We've gathered a whole series of images. What happens next? The next thing that we do with the system through the Outfield, or what we do with that data through the Outfield system, is we start processing it to deliver insights. And the phrase we always use is actionable insights. That's always what we're driving towards. That's always what we're pushing towards. We've got 3 examples here on the screen, and these are the 3 main insights that the Outfield system gives to users at the moment. We've got blossom variability, first of all, on the left-hand side, this pink and white map. This is a map of blossom loading, of open blossom clusters across an orchard. Pink areas are where you've got a higher loading of blossom per tree across the orchard. So in the pink areas, those trees have a lot of blossom on them. The white areas are lower loading of blossom. Our farmers are using these maps to really assess and analyze what's going on during that crucial blossom period on their orchards. This kind of map was generated from a 10-15-minute flight using a drone, processed using the Outfield, and available within 24 hours to be looked at. Growers are using this to identify areas where you've got a lot of blossom in the orchard. So that might be somewhere you want to go and apply thinning, maybe a chemical thinning or a mechanical thinning. And they're using it to look for areas where you've got a lot less blossom across the orchard, especially if you see those areas being, having a lot less a lot less blossom consistently over several surveys. You've got an area where the trees are for some reason producing a lot less blossom. You might want to target these areas for a field walk by your agronomist. You might want to send someone out to go and inspect for disease pressure or something like that. We're also using these maps to drive precision spray systems. So we've got a few growers here in the UK mainly that are using these maps to feed into precision spray systems for thinning. And I'll talk about that a bit in a couple of slides' time. In the middle, we've got a fruit variability map. Similar kind of idea, but now we're not looking at blossoms, we're looking at the loading of fruit across the trees. Again, this is a 10-15-minute flight with a drone. Data is produced and is available within 24 hours for the grower to view. And this is showing dark blue are areas where we've got more loading of fruit per tree. So those trees are heavily loaded with fruit. And the lighter areas are the white areas where you have fewer fruit per tree. So growers are using these maps to identify where you've got more, where you've got higher yielding areas, but also to identify quality issues. If you've got a lot of fruit on the tree, too many fruit on the tree, you may have size issues. Too many fruit, you're going to be producing a lot of quite small fruit on the trees. And similarly, with areas where you have fewer fruit on the trees, you might have fruit that are too large for your size spec. But it also might be an indicator of other pressures. You might have soil quality issues, you might have disease pressures and things like that. Growers are also using this data to try and optimize their management of orchards. So optimizing where they're doing thinning. If you're doing a kind of a manual hand thinning or manual interventions, very expensive, very time consuming in terms of your labor usage. You can use this kind of map to identify where you want to be sending those workforces, those labor teams. So you're being a lot more efficient there. And then it's simple things like where do you put your bins when it comes to harvest? So producing these maps just before harvest, where have you got more fruit, where have you got fewer fruit? When you're just laying out your bins for the pickers to drop the apples into when they're harvesting, where are you putting those bins? Well, you put those bins where you've got those concentrations of fruit. That's what makes sense. And then your pickers are they're walking less to get to the nearest bin. You're saving yourself time. You're covering those orchards more quickly. You're being more efficient with your labor. So there's all sorts of ways that growers are using this data to optimize their orchards. The last insight that the Outfield system gives you at the moment is tree size. This is the green and white map that we've got here. And this is a map of the tree size of all the trees across the orchard. Again, dark green is where you've got a larger tree size, and white is where you've got a smaller tree size. And when we say tree size here, we mean the top-down diameter, the spread of branches on those trees. And so growers are using this map or these maps to identify areas of high vigor and low vigor. And we have a grower in South Africa who's carrying out a trial at the moment using these maps to identify zones of the orchard where she's going to do a fertilizer application, a precision fertilizer application. So she's only applying fertilizer in the areas of the orchard where the trees are a little bit weaker, and saving that fertilizer in the bits that just don't need it. Obviously very topical with the way that fertilizer prices are going at the moment. So that's a really exciting trial that we're doing. And again, another example of how you get these insights and how you can use it to optimize your orchard, producing more fruit, getting better trees, more productive trees, getting the right number of fruit, more fruit per orchard, per tree, per orchard, just by using these insights, just by using this data, feeding back into that idea of that fourth agricultural revolution, producing more from the same area of land, from the same units of energy, from the same energy inputs, and with using less labor. Tying this all together then, this is an example of the Outfield web app. And again, for anyone on this call who's using the systems will be very familiar to you. This is the Outfield web app. This is how we're presenting our results back to our users at the moment. This is an example of the web app presenting a blossom density map like we just saw on that previous slide. And the main thing I want to draw your attention to is that timeline down the bottom. So you've got that timeline down the bottom of the screen. So if you're a user of this platform, you can look at this data today, and you can scroll backwards and forwards. Well, can't scroll forwards, but you can scroll backwards in time, and you can see what that orchard has been doing previously throughout the rest of the season and in seasons beforehand, comparing that data, getting real insights into trends, into what's going on in that orchard this season, previous seasons. So I touched on this a little bit previously, but this is another area where we're really focusing, where we're really trying to make that data work harder. This is something we're really focused on here at Outfield, is using our maps to drive applications in the orchard. Mostly that's spray applications, although we are doing this trial with fertilizer applications, and we're looking at a few other applications as well. But mostly it's around spray applications. It's great having these really nice, pretty maps and having really nice ways to view them, but you've got to make these maps work for you. You've got to make this data work for you. So we've got two sprayers here. One on the left is a traditional spray system, and you can still use this kind of system with Outfield. So the farmer here might be tasking the spray operator to only spray certain sections of the orchard, which require it, maybe for thinning applications or such like. You might only decide to spray the west side of the orchard, or only spray these 20 rows and then stop. So you can give those kind of, semi-intelligent, semi-precise instructions to the spray operator, optimizing your applications using existing equipment just by having more data and having more insights. But where it gets really exciting is this sprayer on the right-hand side. This is the PODS sprayer, P-O-D-S, PODS sprayer. This is a spray system that has been developed over the last couple of years here in the UK by a consortium of partners, including Outfield. We provided a lot of the maps, a lot of the mapping that went into this system. Really exciting system. This is a PWM-driven spray system, which is RTK GPS guided. So it has a precision GPS system on top. In fact, it has two, one on the tractor, one on the sprayer. And it's able to spray trees, individual trees across the orchard with an individual dose. Not just individual trees, it's able to do individual bands, height bands up and down the trees. So you can do the tops of the trees and you can do the bottom of the trees. And because it's PWM driven, you can spray different amounts of chemical as well. So you can do an individual tree, you can do an individual portion of a tree, and you can do a precise rate of application on that portion of the tree. So really exciting, incredible level of resolution that you can get down to with your spray applications. But that's only as useful as the maps that drive it. And so we've been working to generate these really high resolution maps of orchards in terms of tree height, tree size, number of blossoms, all sorts of things. And there's work going on at the moment on that system as well. So that's an example of being able to take the data, the kind of data that Outfield is providing and generating, and turning it into real applications and real insights on the farm. If you're treating every single tree individually, you can drive incredible homogeneity. That's the goal here, is to drive homogeneity across all your trees, making every single tree in your orchard look identical. Because if every tree looks identical, then you're going to be maximizing the yield, maximizing the output from this orchard. Not by putting down more chemical, but actually by putting down less chemical. Less is more, right? And so tying back again to that idea of that fourth agricultural revolution, can we produce more from the same area of land? Can we produce more using the same or even fewer resource inputs? And so then the last bit of Outfield I want to talk about here is forecasting. This is the most important feature that we consistently hear this from our users. This is the one that they really want. This is the kind of the game changer for them. And this is where we focus most of our energy and most of our development. Forecasting and yield estimation for orchards, for commercial apple orchards. Can we predict with accuracy, quickly, reliably, and in a responsive way, can we predict the yield of an orchard weeks, months ahead of harvest? And the answer is yes, we can. We can. So this is an example of an Outfield yield estimation map. We're showing 3 different zones here: medium, low, medium, and high, different productivity zones of the orchard. And that's generated from those fruit maps that we saw earlier, those blue maps, and also those tree size maps, those green maps that we saw earlier. Pulling that information together, we're able to produce a yield estimation map for an orchard. It's a map showing you where you've got productivity in the orchard, but much more than that. We've got data in terms of the number of fruit, the amount of fruit that's going to be produced in tons, in bins, and also in number of fruit, if that's of use to you. As I said, this data is being produced 3 months before harvest, 2-3 months before harvest. That data can be available to your sales team, it can be available to your marketing team. It can be available for your transportation and storage, so you can optimize those. It allows you to do your pre-sales. It allows you to negotiate your contracts with confidence. It's accurate yield estimates months in advance that you can rely on, that you can have confidence in. So this is an example. And then why are we doing that? We're doing that to reduce the amount of wastage. We see, the industry sees wastage through transportation, through storage, through not negotiating the right sales contracts, not matching up that supply and that demand, over predicting your yield, under predicting your yield. It all leads to, and it can lead to wastage throughout the supply chain. No one wants that. No one's growing apples to have them go to waste. We all want to grow fruit, to have it sold, to have it bought by the consumer. And so just by applying more data to the orchard, we are hopefully reducing the amount of wastage, reducing that waste coming out of the orchard, which has the net effect of increasing yield. So we're increasing yields on that farm from that same area of land, from that same energy input, increasing the amount that field is producing, tying back again to that fourth agricultural revolution, those ideas of producing more from less. At the moment, our yield estimates are all based around fruit counting, and we're doing a lot of work at the moment as well on fruit sizing, and even a little bit on fruit color. And we've got more to say. We'll have more to say about that over the course of this season, over the course of this Northern Hemisphere season, and rolling into Southern Hemisphere season later this year, on how we're measuring that fruit size and how we can tie that into yield estimates, not just for quantity of apples, but also for quality, for fruit quality as well. So really exciting space. There's a lot of stuff happening here, and it really does unlock, it goes far beyond the farm. It unlocks the supply chain, all the way down the supply chain, unlocks efficiency savings. So we've talked quite a lot about how Outfield is using data and the specifics of where we're gathering data and what we're trying to do with the data, and a few examples of how that data is being applied. There is so much potential for this data. I've talked a lot about crop monitoring, which is what the Outfield system does, but you can take that same story and you can repeat it with a smart irrigation system, or you could repeat it with a robotic harvesting system or robotic transportation systems. The fourth agricultural revolution, it's happening in lots of different areas, and hopefully those efficiency savings and those those yield increases are happening all over the place. But for us, a lot of that efficiency, especially around automation, it's driven by data. It all comes from having really good farm level data. And so we sort of think about data as a maybe a timeline, a product roadmap, however you want to think about it. There's a few ideas we put on the screen here. Outfield is really focused on those first 2 points: understanding data and forecasting data. I've talked about that quite a lot. Producing maps, producing metrics, producing parameters. What can you do with those? How can you use that to optimize your orchard now, today, this year? Forecasting data. What are you going to be getting this season? What are you going to be producing at the end of this season? What's coming down the pipeline? What's coming down my sales, my supply chain? So Outfield is focused a lot on those two. And moving forward, we're going to be focusing a lot more on those next two sections on this roadmap: automation and modeling. Automation, I'm sure we're all familiar with robotic systems for picking, but there's a lot more automation that has to happen on the farm. Picking is only a couple of months of the season, right? You've got pruning that needs to take place. You've got spraying, which we've talked about quite a lot. You've got root pruning, husbandry, transportation, storage management. There are a whole host of areas where automation can help, and all of that really, really needs to be data driven. You can't be sending out robotic harvesters and having them work efficiently unless you know what to expect from that orchard, unless you know where you've got the crop in that orchard and how much crop you're going to get. And then that next bit, modeling. Tying all this data together. I've written down there a digital twin, the idea of having a digital twin. This is something we're an idea we're playing around with. It's an idea you might have heard of, talked about in the space, or talked about in agriculture more generally. But the idea of having a digital twin for every orchard in the world, a really, really powerful idea. What do we mean by digital twin? I'll explain a little bit, because it's a bit of an odd concept. The idea here is to model in quite a lot of resolution, as much resolution as possible, each individual orchard. So these are not models that you can apply to all, gala production or all Honeycrisp production. This is a model that is specifically tied to that orchard. It's a physical representation of the orchard. So the trees, the rows, the boundary of the orchard. It might include soil data. So you might include soil maps in this. It's going to include environment data. So your weather data, what's the climate, what's the sunlight hours, the number of cold units, the amount of rainfall that orchard is seeing. It ties in disease models as well. So you're predicting disease pressure. And then obviously that crop monitoring aspect, which is what Outfield is doing. So tree size, tree counts, where you've got missing trees, how many blossom were on that tree, how many fruit were on that tree, what was it like this season, what was it like 2 seasons ago. What does that allow you to do? Having that model, tying all that data together, allows us to start doing a whole host of things. You can use it to look at or to forecast and get predictions on disease pressure. So you're running a lot of sort of risk models on disease. What disease could I expect? What risk have I got from disease in this orchard? Where am I going to see that? Where am I likely to see that? You can start to do things like yield estimation or yield predictions years in advance. So looking back over the last couple of seasons, I've had this yield output. What can I expect to see over the next few seasons, next season, the year after? You can start to do economics modeling. So what are the inputs? What, on a orchard by orchard or a parcel by parcel, block by block basis, what are my inputs to this orchard? And what are my revenues? What are my outputs? How many fruit am I going to be producing? What size can I expect from that? So tying in economics data, apple pricing data, fruit pricing data, market data. How much am I spending on this orchard? How much am I making from it? Is this orchard economical? Which of my orchards are the most economic? How do I bring all my orchards up to that standard? You can start to that kind of thing. And you can start to simulate as well. So also being able to simulate for a given orchard using this digital twin, using this model, what will this orchard look like next year if we have a particular cold snap, if we have drought conditions, if climate change. So not just in next season, the season after, in 5 years' time, in 10 years' time, is this the variety that I need to be growing? Do I need to be thinking about other varieties? Maybe here in the UK, A traditional variety that we grow is Cox apples. And they just, Cox is on the way out. It's just not suited to modern conditions. It hasn't really kept up. And so we're seeing that decrease in Cox, and we've got new varieties coming in. So are you growing the right varieties? That's the sort of thing that he answered with this digital twin, this model idea. And then the last aspect of it really is environmental. What are the environmental impacts of this orchard? What's my biomass for this orchard? What's my carbon capture looking like for this orchard? Is that going to be a thing that fruit farms of the future have to think about? Capturing and storing carbon and trapping carbon. A fruit farm is a fantastic carbon sink. Can farmers make use of that? Can farmers monetize that? Well, by having a digital twin, by having a model of the orchard, hopefully you can track that, you can follow that, and you can monetize that. So that's the idea of a digital twin. It's a concept we're playing around with. It's something we're thinking about all the time. It's something we're kind of building towards. If you've got ideas on that or thoughts on that, please do get in touch. It's something we're really exploring. So data, the title of this talk is the future of fruit farming. And I said at the beginning, spoiler alert, it was going to be data. This is why we think it's data. We really see a power in data on fruit farming, because we're talking about high value crops, because there are those, quantity and quality are so important to the economics for this industry, because they're so labor intensive, or they can be labor intensive. Data has such potential to unlock efficiency savings and to unlock potential from these farms. So the future really for us, data driven. So having said that, there are questions we need to answer around data. There's a big topic at the moment around data ethics. And data is what we do. Outfield, we are a data company. We're really passionate about it. And so there's a few questions up on the screen that people might want to think about. But I guess there's a question here, which is, how are we making sure that we're using this data as ethically and as efficiently as possible? If we think about the fourth agricultural revolution compared to the third agricultural revolution, right? The green revolution, where we had these high capacity nitrate fertilizers that came along, we were suddenly able to massively produce yields across the world. Well, looking at the fourth agricultural revolution, if data is the fertilizer of the future, how are we using that fertilizer efficiently? Who has access to it? Who's owning that? Who's managing that? Who's controlling that data? This is something we're really passionate about. We think about a lot. These are sort of questions that we're always asking ourselves. Our customers are asking us. We're asking our customers. We're always thinking about. I guess there's one topic one thing I want to mention on this slide as well. Mention here. Last year there was a code of conduct, which is the first one that we've seen in the industry, released in Australia. I think it's the Australian Farm Regulation Code, something like that. It's a data sharing framework by the industry for the industry around farm data. Who should be thinking about that farm data? What are the guidelines for generating that data, for sharing that data, for controlling access to that data? That's really exciting. So thinking about data is something we spend a lot of time doing. We're very passionate about it. And so, as I sort of wrap up this, I wanted to come back to this scenario which I posed at the beginning, the idea of this, the fruit farm of the future. How close are we to seeing this scenario in action, where we've got data gathering leading to strong insights, leading to applications, precision applications in the field, and data sharing up and down the supply chain, inside the team and between organizations? How close are we to seeing this scenario? And hopefully the answer is we're close. We're very close. And that's something that we're working towards all the time at Outfield.